Hello everyone, and welcome to Team 1's final presentation. For our presentation today, we will go over the methodology we use to compare our API. We will then analyze the two API we will be comparing and pick one out of the two that we deem fits the mold of achieving our methodology's improvement to UX strategies the best. We will wrap everything up with a conclusion and final thoughts on the project.
What is Baymod's method? Baymod's research methodology was a 110,000 hour UX e-commerce research study to gain more traction to their e-commerce side. This broke down into 4 different groups or steps, and the first step was the one-to-one moderated qualitative think aloud testing. The second was the benchmarking methodology. The third one was the eye tracking testing, and the fourth one was a quantitative studies. I wanted to quickly go over the steps and how they use them. The first step, the one-to-one moderated qualitative think out loud testing, was 22 rounds with 3,600 test subjects. Since there were so many test subjects, the aim wasn't to focus on how many people would run into these issues. Rather, they wanted to examine people online and see what will most likely cause interface experience issues and usability issues for a reasonable subgroup of users. They did this by one-to-one usability testing. Each subject had 2 to 4 tasks. Subjects were asked to act like if they were at home, meaning be free and act casual. When problems occurred, they were asked several questions about their thinking process. If subjects couldn't get past a problem, it was considered a failed task. If subjects misinterpreted a problem, it was considered a failed task. Compensation was given. Moving on to benchmarking methodology, it was 45 rounds of manual benchmarking from top grossing US and European e-commerce sites, and they were being cross-referenced by 659 UX guidelines. Each site was graded on a 7-point scale, and there was also an algorithm that was being used to help calculate these numbers. The next step was the eye tracking. In this, they gave the subjects an objective, and they just basically followed their eyes to see how they would interact with the e-commerce website and see where they would go and just follow them along. The last step was the quantitative studies, which was 10 sites with 116,425 participants. The studies each sought answers on research, and these research questions could be anywhere from reasons for checkout abandonment to A/B testing 2 different versions of free shipping. Now going on to the next slide, why we chose Baymod's method. Because Baymod's UX method is both extensive and effective, right? We just looked at how detailed these testings were and how many people were involved. It was such a big trial, and it was so extensive, and the way they went deep about it is something that we felt like we could use, and it should be used, especially when it comes to UX research. And then lastly, AI can be unpredictable. And that's just really the reality of the situation, knowing that AI is a newer thing. So the more people that we have checking all these things out and seeing the perspective of how users navigate through AI, we can do what Baymod did and solve for any future problems that arise.
The first API we chose to analyze was Honeycomb Query Assistant. We initially chose to analyze Honeycomb because of how clean and easy to read the first page was. The main use for Honeycomb is that it can retrieve telemetry data, which is data that can tell the user how well and fast their website or program is. As an overview for the platform, Honeycomb is an observability platform to assist engineers and developers in obtaining valuable insights into their work. Honeycomb is used by companies such as Slack, HelloFresh, and Intercom. Honeycomb allows engineering teams to group results by unlimited high cardinality dimensions and presents query results in less than 3 seconds. Engineering teams using this tool can quickly analyze the mass amounts of data needed to fully understand user experience in complex systems. The platform provides the ability to trigger single alerts before UX falls below acceptable targets and monitors what's important to the users with service level objectives. As a result, engineers save time troubleshooting, leading to reduced downtimes and fewer bugs experienced by customers. Just so you can get a feel of the platform's layout, here's a screenshot with the inclusion of the dashboard's many portal options to the left. This is, of course, collapsible for a clean and less distracting feel while you work. As of May of this year, Honeycomb has used AI to integrate text-to-code communication with its data and covering systems. This destroys the barrier of entry to users who have little knowledge of front-end coding. This is an amazing feature that makes communication easier and bridges the gap between marketers and developers. Of course, this doesn't mean that the skill of coding will soon become obsolete, but this is a step in a more casual, user-friendly direction. Along with the integration of OpenAI, Honeycomb has added other AI assistant features, such as their Query Assistant AI tool to complement their machine-assisted system, BubbleUp. BubbleUp helps engineers identify what questions to ask, and Query Assistant suggests how to formulate that question. These tools streamline the user experience and integrations with the system. The reason they call this feature BubbleUp is it helps users pinpoint anomalies faster, as the skewed data seems to, quote, bubble up, amongst the rest. BubbleUp helps users debug faster, as it streamlines pinpointing these anomalies. The image is not only an ad for this new feature, but also highlights where we see the outliers in this case, showing that the feature is working. This ad is also a good example of Honeycomb's data visualization capabilities. Now let's go into the pros and cons of Honeycomb. For the pros, which we pretty much already went through, is it has a unique integration of AI that streamlines processes that would normally take hours, in addition to allowing developers of all skill levels to be able to access data through its AI inquiry assistant. Something we haven't touched on as of yet is Honeycomb's documentation page, which is very thorough in teaching new users how to use the API. They teach everything from how to install it, use it, how to add new integrations to make the API cater to you and your team, to even how to observe the data. It even has a sandbox mode that allows you to play with the API before installing. It shows you all the steps that need to be taken in every language it supports. Now, as for the cons, it can be confusing to navigate for first-time users. Though it has a collapsible dashboard, it does use some language that needs to be learned before being able to use the platform. In addition, it isn't fully capable to be used by non-developer users. You need to know one of Honeycomb's supportable languages in order to fully use the platform. As mentioned on the previous slide, here are some screenshots of Honeycomb's Quick Start page to help users get started with the API. To reiterate, this page teaches users how to send data into Honeycomb, how to make and where to find data visualizations, how to read the results of the visualizations, and much, much more. On the left, we can see that Honeycomb has a sandbox mode for those who want a trial. They also support integrations if you need to add more features that they don't already supply. From the startup page, we can see that Honeycomb supports JavaScript, Python, and many other languages.
Now moving on to Kibana. Kibana is a data visualization and exploration tool used for log and time series analytics, application monitoring, and operational intelligence use cases. Kibana stands as an open source tool crafted by Elastic, the company behind Elasticsearch. Its purpose is to function collaboratively with Elasticsearch, a highly distributed RESTful search and analytics engine. This collaboration results in establishing a comprehensive basis for tasks such as data storage, retrieval, analysis, and visualization. Through Kibana, users can access an intuitive web-based interface, enabling them to generate personalized and distribute dashboards and reports using data stored in Elasticsearch. Elastic offers powerful and easy-to-use features such as histograms, line graphs, pie charts, and heat maps stored in Elasticsearch. Many companies use Elasticsearch in their tech stacks, including Uber, Shopify, Robinhood, and Instacart. How has Kibana incorporated AI? Well, Kibana uses machine learning as it forms a crucial part of the Elastic Stack, a collection of open source tools created for real-time data searching, analysis, and visualization. It empowers you to identify anomalies, detect patterns and uncover trends within your data, enabling you to achieve deeper insights and base your decisions on data-driven information. Here is an example of how Elastic Platform seamlessly incorporates powerful machine learning and AI capabilities directly into solutions. Elasticsearch also offers built-in machine learning capabilities that can be used for tasks such as detection, classification, and regression. Some of Kibana's pros are that the capability to incorporate machine learning models and algorithms, enabling the discovery of concealed patterns and enhancing the accessibility of predictive analytics. It also allows you to create real-time monitoring dashboards, which can be especially useful for tracking and responding to live events, metrics, and logs. Now moving on to the cons. Despite Kibana's user-friendly interface, becoming proficient in its advanced functionalities, including complex visualization and data transformation, may entail a learning curve, particularly for individuals new to the data tools. Though Kibana does offer security features, setting up comprehensive security settings, user access controls, and integration with authentication systems can be complex, especially in enterprise environments.
We compared the two API platforms using Baynard's method. A key aspect we identified for the Honeycomb platform was their integration of OpenAI, which they named BubbleUp. The tool allowed users to input questions in plain English rather than in code, opening the use to users without a development background. Honeycomb also provides extensive information to familiarize new users with the platform, though it can only produce generated data. Kibana, on the other hand, allowed users to input raw data rather than code, and the platform can produce both generated and non-generated data, as well as data visualization. The main pain point we faced with Kibana was their overwhelming quick start guide. The information was hard to digest and would confuse new users without a development background.
So, after using Baynard's method to compare the platforms of Honeycomb Query Assistant and Kibana, we came to the conclusion that our team preferred Honeycomb. The reason we chose Honeycomb is that we found that between the two, Honeycomb was by far more user-friendly and easy for beginners. When you land on Honeycomb's homepage, there's a button that gives you the opportunity to book a demo and sign up for one-on-one help with Honeycomb technical experts. There's also a sandbox mode that allows you to play with the API before installing. Next, the website also uses neutral language that is understandable for both beginners and those who are already comfortable using the platform. For those who still need the extra help, on the right-hand side, there's also a Get Help section and also a Learn section, both which include very helpful links and videos for beginners. Another helpful factor Honeycomb has is its OpenAI query assistance. We found that by incorporating this, Honeycomb found a hole in the market, took advantage of its popularity, and implemented AI in order to fill in the gaps for their users. Now, Honeycomb can be used by non-developers as well as beginners, at the very least to play around with the platform. Honeycomb improved their user experience by incorporating AI and giving the chance for beginners to be able to use the platform as well. By doing so, they have also stood out from their competitors as well.
Although Honeycomb and Kibana are similar APIs, Kibana's counterintuitive quick start page landed them in second place. Honeycomb seems to be on the leading edge of integrating tools to support both developers and non-developers seeking to use the API platform. Their clear quick start instructions, options for users to input questions in English rather than in code, and integration of the BubbleUp AI tool led us to prefer this platform. Suggestions for them to further improve their UX would be to add a help button to the BubbleUp tool for users to ask quick questions, and in the initial days of their use, survey new users to tailor the UX to their specific needs.
Here's our works cited, and thanks for watching. We hope you enjoyed the presentation.